Assalamualaikum warahmatullahi wabarakatuh and good morning to Dr. Ruslawati. Today we will present chapter 3 about hydrodynamic. Before we start, for the first slide, I would like to introduce myself first. My name is Nuri Umaira binti Ruslan, matrix number 06DKA20F1082. Okay, now we go for the first slide. Okay, the first one, introduction and overview of the topic. The second one, we will learn about concept flow in motion. The third one, relation percent of shear stress or Reynolds number. And the last one is conclusion. Okay, we go to introduction about hydrodynamic. What is hydrodynamic? Hydrodynamic is basically the study of fluid in motion. It provides a link between pressure, velocity, and the geometry, which is size of pipe which flow is occurring. In addition, Bernoulli principle, which is basic to the science of hydrodynamics, says that the faster a fluid substance flow, the less outward pressure is exerted. Okay, the next one is concept flow in motion. We have a few concept flow in motion and we will see one by one. The first one is real fluid and ideal fluid. What is real fluid? Real fluid is fluid which do possess viscosity. This fluid always offer shear resistance. And ideal fluid is fluid which don't have viscosity and are incompressible. This fluid do not offer shear resistance. Next is compressible and incompressible. Compressible, that means a flow that undergoes a notable variation in density with trending pressure. And incompressible refer to the fluid flow in which the fluid density is constant. Next one is uniform and non-uniform flow. Uniform flow, if the flow parameters remain constant with distance along the flow path, and non-uniform flow if the flow parameters vary and difference at different points on the flow path. Open and closed system. Open system, both mass and energy allow to transfer across the system boundary. And closed system, no mass transfer, but energy may transfer across the system. Steady flow, if the flow parameters do not vary with time or are independent of time, then the flow is steady. Okay, we see the next slide. Is still concept flow in motion. Okay, flow visualization. Okay, one of the most important tools in understanding fluid mechanics is being able to visualize what is going on in our system. A few standard visualization methods of use to visualize that study flow. Okay, the first one is streamline, second one is path line, third one straight line, and the last one is timeline. The next one is 1, 2, 3 dimensional. 1, 2, or 3 dimensional flow refer to the number of space coordinates required to describe a flow. It appears that any physical flow is generally 3-dimensional, but these are difficult to calculate and call for as much simplification as possible. This is achieved by ignoring changes to flow in any of the directions, thus reducing the complexity. It may be possible to reduce a 3-dimensional problem to 2-dimensional one, even a 1-dimensional one at a time. Okay, the next one we will see the example of flow in motion. The first one is real and ideal fluid. One is compressible and incompressible fluid. The third one is steady and unsteady flow. The last one is uniform and non-uniform flow. The next slide I will pass to my team members.
Hello madam, my name is Nurhanani Zaina binti Muhammad Nur Jafri. My matric number is DCC30122 FLUIDS MECHANICS. Now it's my turn to talk about relation present of shear stress of Reynolds number. First of all, there are three types of low Reynolds numbers. Okay, first is laminar, second is transitional, and third is turbulent. Okay, as we can see at the picture here, laminar is at the low velocity, turbulent is at high velocity, and the transitional at the both of laminar and turbulent, which is they are not too low and too high. So, what is laminar? Laminar is every fluid molecule followed a straight path that was parallel to the boundaries of the tube. This is when the Reynolds number is less than 2300. Next, transitional. What is transitional? Transitional is every fluid molecule followed wavy but parallel path that was not parallel to the boundaries of the tube. This is when 2300 is less than Reynolds number and Reynolds number is less than 4000. Last one, turbulent. Turbulent is every fluid molecule followed very complex path that lead to a mixing of the dye. This is when Reynolds number is more than 4000. Next, Reynolds number. Okay, Reynolds number is important in analyzing any type of flow when there is substantial velocity gradient or shear. It indicates the relative significance of the viscous effect compared to the inertial effect. The Reynolds number is proportional to inertial force divided by viscous. Reynolds number, the non-dimensional velocity, can be defined as the ratio inertial force to viscous or friction force, and interpret as the ratio dynamic pressure is to shearing stress. Next. So, the picture at below is the formula of Reynolds number. As we can see at here, RE is Reynolds number, P is density, D is inside diameter of pipe section, M is dynamic viscosity of the fluid, U is kinematic viscosity of the fluid, and V is flow velocity. So, this is the question and how to find the Reynolds number. At the left, we have the formula of Reynolds number. So, the question is, a Newtonian fluid with a dynamic viscosity of 0.52 ns per meter square with a density of fluid 918 kg per meter cube flows through a 50 mm diameter pipe with a velocity of 2.6 meter per second. Determine the type of low Reynolds. So, first of all, what we have to do is we have to take out the point first. So, the point can we see at here is dynamic viscosity, density, diameter, and velocity. So, we write down all of the points at the below, and then we put the point at the formula. So, the answer we can get at here is 2045. So, 2045 is a laminar less than 2300. So, this is the last part, which is the conclusion of us. What we can get is this hydrodynamic is very necessary in daily life because what we do is mostly hydrodynamic elements. From this topic 3, we can learn the concept in hydrodynamics in more details. For example, real fluid, ideal fluid, compressible, incompressible, and others. Here we can also learn how to calculate the Reynolds number easily because we have learned the formula and how to calculate it. It is not so difficult if we are accustomed to using the formula that has been provided. So that's all our presentation about topic 3 from my teams, which is me and Nurin Umaira. I hope Dr. enjoy our presentation and have a nice day, Doctor. Thank you.